Hi friends, in this video we see some objective type questions. The first question is the material through which electric charge can flow easily is. The options are quartz, mica, germanium, copper. The correct answer is copper. In copper material, the current flow easily. That is, the electric charge can flow easily. The next question is the current flowing in a conductor is proportional to. The options are drift velocity, 1 by area of cross section, 1 by number of electrons and square of area of cross section. The correct answer is drift velocity. So drift velocity means is the velocity with which free electrons get drift towards the positive terminal when an electric field is applied. That velocity is called the drift velocity. Okay, so the current is proportional to the drift velocity. Next question is, if the length of a copper wire has a certain resistance R, then on doubling the length its specific resistance. Okay, so the copper wire resistance R. Okay, now now we double the length of the copper wire, then what is the specific resistance? So the options are will be doubled, will become 1 by 4th, will become 4 times, will remain the same. Okay, so the answer is the specific resistance will remain the same. Okay, it can't change. The next one is when two ohm resistance are in parallel, the effective resistance is. Okay, here resistance are connected in parallel. So two resistance are, first resistance value is 2 ohm, then second resistance value is 2 ohm. Okay, so the resistance are parallel. The effective resistance mean that is total resistance. Okay, so total here use the formula 1 by R1 plus 1 by R2. R1 equal to 2 ohm, then R2 equal to also 2 ohm. Okay, substitute the R1 R2 equal to 2 ohm, we get the answer 1 ohm. Okay, so the correct answer is C, 1 ohm. The next one is, in the case of insulator, as the temperature increases, resistivity. Okay, options are decreases, increases, remains constant, becomes 0. Okay, so insulator means here resistivity is very high. Okay, so as temperature increases, resistivity temperature decreases, resistivity increases. Okay, the correct answer is B. Answer B, increases. Okay, so the next one is, in a thermocouple, the temperature of the cold junction is 20 degrees Celsius. The neutral temperature is 270 degrees Celsius. The temperature of the inversion is. Okay, so the options are 520 degrees Celsius, then 540 degrees Celsius, 500 degrees Celsius, then 510 degrees Celsius. Okay, here the answer is 520. Okay, use the formula theta C plus theta I by 2 equal to theta N. Theta C is the cold junction. Okay, that is 20 degree, plus theta I is the inversion. Okay, that we find out. Okay, so the temperature of inversion is we find out. So theta I by 2 equal to theta N, that is neutral temperature 270. Okay, substitute this value and we get the answer. The answer is 520 degree Celsius. The next one is, when n resistors of equal resistance are connected in series, the effective resistance is. Okay, now the number of resistance, that is n resistors connected in series, then what is the total resistance? Okay, so in resistance connected in series, that means that is R1 plus R2 R3, that's like. Okay, but in parallel connected, 1 by R1, 1 by R2, 1 by R3. Okay, so here the resistance are connected in series, so the correct answer is D. Okay, NR. Okay, so the next one is Joule's law of heating is okay, Joule's law of heating is H equal to VIT. Okay, that is the amount of heat produced in the time T is the Joule's law of heating, that is H equal to VIT. Next one is nichrome wire is used as the heating element because it has. Okay, so heating in all the heating elements nichrome wire is used. So what is the reason for used a heating element? What is the reason for used a nichrome wire in a heating element? That is, here four option is, the first one is low specific resistance, then second one is low melting point, third one is high specific resistance, and fourth one is high conductivity. Okay, so nichrome wire has the property, it's a high specific resistance. Okay, so the answer is D. Then not only high specific resistance, then it also has high melting point. Okay, so high specific resistance, high melting point. And that's the reason we use the nichrome wire in heating element. Okay, so the next one is Peltier coefficient at a junction of a thermocouple depends on. The options are the current in the thermocouple, the time for which current flows, the temperature of the junction, the charge that passes through the thermocouple. The answer is C, that is the temperature of the junction. Peltier coefficient pi is depends on the temperature of the junction. Next one is the period of revolution of a charged particle inside a cyclotron does not depend on. Okay, so the period means that is time t in of a charged particle in cyclotron does not depend on. Okay, so what is that? First four option, the magnetic induction, the charge of the particle, the velocity of the particle, the mass of the particle. So the answer is C, that is the velocity of the particle. The in cyclotron the period t is not depend on the velocity of the particle. Okay, then phosphor, the next question is phosphor-bronze wire is used for suspension in a moving coil galvanometer because it has, okay, high conductivity, high resistivity, large couple per unit twist, then small couple per unit twist. Okay, so here the answer is D, small couple per unit twist. So we use the phosphor-bronze wire in a moving coil galvanometer. Next one is, of the following devices which has small resistance. Okay, the options are moving coil galvanometer, ammeter of range 0 to 1 ampere, then ammeter of range 0 to 10 ampere, then voltmeter. Okay, so in small resistance the answer is ammeter of range 0 to 10 ampere. So ammeter is the measurement of current. Okay, so it has the range 0 to 10 ampere, it has a small resistance. Okay, so the next one is an ideal voltmeter has, options are zero resistance, finite resistance less than G, that is galvanometer resistance but greater than 0, resistance greater than G but less than infinity, then infinite resistance. Okay, so voltmeter has, ideal voltmeter has infinite resistance. The answer is D. Okay, so that's all friends. Thank you.